In this example, we would like to calculate how much rotational kinetic energy is stored in a certain object that is rotating about a fixed axis of rotation. So let's begin. Let's suppose that a large industrial disk with a diameter of 15 meters is used to store rotational kinetic energy. Now, if the disk has a mass of 100,000 kilograms and it can reach a frequency of 120 revolutions per minute, let's calculate how much rotational kinetic energy is stored in our object. So here we have the following object, a disk, which is a rigid solid cylinder. Now, the point or the center of mass is the point through which our axis of rotation passes. And the distance from the axis of rotation to any point along the disk is half of our diameter, so 7.5 meters is the radius. Let's suppose our disk is rotating in the positive counterclockwise direction. So to find the rotational kinetic energy, we have to use the following formula. 1/2 multiplied by the moment of inertia of the object multiplied by the square of the angular velocity. So, in the first step, we have to convert frequency from revolutions per minute to revolutions per second. Then in the second step, we can use the frequency to calculate the angular velocity. In the third step, we calculate the rotational inertia or the moment of inertia of the object. And in the final step, we use this equation to solve for our kinetic energy of the rotating object that is rotating about a fixed axis. So let's begin. The frequency is equal to 120 revolutions per minute multiplied by 1 minute divided by 60 seconds, and we get 2.0 revolutions per second. In the second step, to find the angular velocity, we take the product of 2 pi and the frequency found in part A. So 2 pi multiplied by 2, we get 4 pi radians per second. So this is the angular velocity of every single point on our rigid solid cylinder. Now, in the third step, recall that in order to calculate the rotational inertia of our rigid solid cylinder, we have to use the formula 1/2 multiplied by mass multiplied by radius squared. So 1/2 mass times radius squared is equal to 1/2 100,000 kilograms multiplied by 7.5 squared. We get approximately 2.813 times 10 to the 6 kilograms times meters squared. In the final step, we simply plug in our values. We plug that into the calculator and we get approximately 2.2 times 10 to the 8th joules of rotational kinetic energy is stored in our object when the object is rotating in the following counterclockwise direction.